Hi everybody, today we look at procedural content generation and how to template it, how to make it easy to use and to avoid working with the graph itself. So target today is explaining a plugin that is freely available. You see the link down there in the description, and with that plugin comes a form that allows you to very easily generate PCG graphs and use as many as you want. For the structure from the plugin, if you have downloaded it here from the URL, you have two structures kind of describing the meshes that we use. We have a primary data asset and the data asset itself building that form. If you look here on the plugins, just copy that plugin into your plugins directory from your project. Then first thing is here you have the f mesh base, that's just a static mesh, and a mesh ID, that's a name. And that name is important for loop control really. And then we have the f meshes that points to the first one into an array. So there's an array of this mesh bases. And then we have a lot of parameters, either bool or floats, that describe how your PCG graph should look like. What's the density? What's the distribution? Is the mesh enabled or not? All these things you can easily just via the mouse click control here. Then you need a primary data asset because that's the prerequisite for a data asset itself. This has one variable called mesh container, and this points to an array of f meshes. That is exactly what your data asset will show, an array of f meshes that you can manipulate. The data asset is here, and under data assets, it points to this PMA mesh container that we just saw. And if you open that, that is then exactly the form that I showed. So meaning here you have, for example, 4 different mesh groups. These mesh groups have a number of meshes, meaning static meshes. They always have this mesh ID that needs to be the same across each of the entries. And then they have a lot of parameters that you can use to manipulate the appearance in the PCG graph. And that's it, more or less in a nutshell. So now the question is, what does the PCG graph do? How do we transform these variables into the graph itself? There are 2 graphs actually. There's the main graph that is quite short, mostly for looping. And if you go here to directory, to the main graph, and you see, first thing, they convert your spline into a surface. So we use a spline in the blueprint actor to define the surface where we want to have our PCG graph. And then we create the surface from spline, that's new in 5.4. Then we have the mesh container variable and split that up. The mesh container is nothing else than your primary data asset here. That's this mesh container variable. That contains an array of meshes. That's here in the second step, mesh container.meshes. That is then exactly the inner loop if you want. So we loop over all these things and then loop over the single meshes and push them all as parameters into this PCG template with these in parameters. Of course, the PCG template has to point to a PCG graph. That is, or this subgraph has to point here to the template, and that is exactly what we will look for. So the main graph is really quite easy, it's just looping. Now let's look what happens in the loop. First thing, we have here an input, and the input comes with different things that we push in there from the main graph. If you use here the Unreal past bin, then you would have to create it by yourself because it's not automatically created from the past bin. Then you would have to see that the label, usage, and allow types are exactly the same. Or you just download the plugin, that's a bit easier. But if you just want to have a look what happens here in the graph, this past bin might be the way to go. Second step, we take all the input parameters and push them into named rerouting nodes so that we have them available without having kind of spaghetti code at the end. And we do that for everything. So we have a lot of these that are always pushed into one kind of singular attribute node. And that is exactly what we will use then down there. So let's now go through it and show exactly what each of them does. First is the surface sampler, so kind of creating our points. And of course, the points can be controlled by the density and the seed and the extents. Then the seed is of course just a random variable that initializes the random distribution. The density will describe how many points per square meter are actually allowed. And here, as I have 4 different mesh groups, the first is broadleaves, then blossom, then we have rocks and grass. I can play around with these densities and then should see immediate results. Important here that the order in which you push these mesh groups into your PCG graph is quite important, because depending on that, either you have enough space or not. So you will see more or less how the density changes with manipulating that. You see, I play around here a bit, and it really depends on the size of your mesh, the size of your graph, and so on and so on, what exactly you see. If your graph is too small, actually you will not see anything. So make sure that it's big enough to actually show something. Extents is the parameter that shows how many centimeters you have between each of these static meshes. So 50 centimeters, naturally I get much more of these trees than with 100. If I put 200 here for the blossoms, then I just get a couple of them, because the density will decrease. So with these 2 parameters, you can play around a bit how many of each you will get. So let's try it here again. That is the blossom. And here you have to play around a bit to make it look a bit naturally. We will look into other options like clustering and how to do that to kind of improve the, let's say, the natural look that you get with that. Next thing is quite important, because you can disable and enable each of these graphs. So you have this enable flag, and if I uncheck it, that's for the green broadleaves, you will see they're just gone. Meaning for all these subgroups, you can just switch them off. Projection means that it is projected to the landscape. Normally your spline will not be perfectly aligned with the landscape. So if I just circumvent the projection, you see I have a PCG graph, but unfortunately it's flying, not really pushed to the landscape. So let's reconnect, and then everything should be again directly here on the bottom. This one here, yeah, it looks better. So that's another important one, but that is normally something that you will leave switched on. Then here the height and the height boundaries. That is the question, on which Z axis in your landscape will the mesh group exist. Normally the standard is between 0 and 100,000. Normally it exists everywhere, but I know around 3,000 meter, whatever unit, it's actually running here through the PCG mesh, and you see the moment I limit the green here, the broadleaves, between 0 and 3,000, then they will just be in the lower part, and if I invert that, they will just be in the upper part. So that's an easy way really to do height-based distribution. The next thing is the slope behavior. So the question, what is the angle where the things will spawn? Here, for example, I just spawn the rocks at the moment on the flat areas, not on the slopes at all. That's simply because I have the slope invert checked here. And yeah, you see, if I push the lower bound higher and higher, I get more and more of these stones. And if I then invert it back, or actually set it back, then it's only slopes where they grow and not the flat areas anymore. It's a bit tricky to manipulate. I might change that into using an angle. That's a bit easier. But really, that's a way to define slopes. What normally is done in an auto material, what I absolutely not recommend. That's not something that should be in a material at all. That should be something definitely that you do either in PCG or in your height map generator, for example, what kind of slopes you have. Then transforms points, that's the classical transforms like scale and rotation and stuff like that. So for example, if I go here to my blossom trees and say my min scale is 10 now, and my max scale, let's push it to something high like 100, I get very big trees because it randomly distributes between 10 and 100 now. Might be a bit big, so let's put it between 3 and 4. And that's the classic one where you can either set scaling. Quite important also set things like offset, min and max. Quite often you want to have a small offset into the negative Z axis to avoid that your static meshes are spawning a bit above the ground, or you can look into the static meshes if they are on a slope, something like that. So best way is really kind of pushing them a bit into the bottom with an offset. Here's the difference. Difference is simply the difference between the points that are already generated and the points that are now newly generated. That is loop control. Self-pruning is a standard node that you can use here. That is avoiding too dense and too much overlapping static meshes here. So self-pruning will normally give you a bit better behavior in terms of things are not as much overlapping as they could be. You can play around with the extents variable that shows what's the minimal distance between two of the same mesh groups. And here with self-pruning, it again tries to limit that further. Neighborhood-based values, this point neighborhood, is a cluster algorithm. So it tries to cluster your static meshes a bit. That's a behavior that you normally see, for example, with everything natural, because normally you have one flower, and then of course the next flower coming from the first one will be around it and not randomly distributed. So all the time, if you distribute something randomly across the landscape, it doesn't look very natural. Normally things are clustering in nature. So everything, if you have plants, you should think about if you want to cluster them around. So again, kind of working a bit with the density and working with this point neighborhood, and look what gives the best results here. You see now the grass is a bit clustered, so it's not randomly distributed. And if I uncheck it, it really gets just this random distribution around the places. And really depending on your meshes, that might look much more natural really. Important is the debug flag that is set in the main graph actually. So if you go back to the main graph, here, the PCG main, then you have a parameter, custom parameter here on the right that says debug. And if you check that, your static meshes will be replaced by these debug boxes. They are a bit overlapping here, or maximal overlapping here for the rocks, I think it is. Let's switch the other ones on. You can define the color of all of them. So if I switch that on, at the moment they are disabled, then you will see these boxes there. And that is normally done to kind of evaluate, for example, if slope or whatever distribution is working, because you normally see them much easier than using your static meshes that might be trees or whatever, and a bit hard to see. Yeah. So here now you see very nice distribution of grass, of blossoms, of rocks, and so on and so on. So meaning that the debug flag is quite helpful to see what's going on in your PCG graph without being actually clustered with the real static meshes. Okay, now we are back to our plants. Let's see what happens here. That is loop control here. So matching inner and outer loop. The match is done via an attribute. That is this mesh ID. And the mesh ID of the inner and the outer loop needs to be equal. And that is exactly what we say here in this attribute filter. So if you look here at the details, it says equals mesh ID for the target attribute and mesh ID for the threshold attribute. That is really making this loop possible. It's a bit cumbersome, but that seems to be the only way at the moment to do it for an array of arrays. Then we spawn the static meshes, and we union the newly spawned meshes with the ones that we had beforehand. So the whole thing makes it really easy to play around, to invent, to add more meshes, less meshes to the whole thing without really having to deal with the graph itself. The spline makes it quite easy to just drop it to landscape and play around really with the areas that it covers. Be aware, as I said, the order is important, the order where you span your mesh groups, because that might really influence the distribution. Because the first one is maybe already saying that nothing can span in its area and has a certain width, and accordingly the next thing will not have the same place to spawn. So think about that. I hope that makes sense, and have fun with it. Download the plugin, try it out, and tell me in the chat if it's working. Thank you.